All right, SAT Practice Test 5, calculator version. Starting right off with number 1 here, reading data. So we have a graph. Let's see what they're asking. According to the line graph above, between which two consecutive, so consecutive means back-to-back years, that there was the greatest change in the number of 3D movies released. So the greatest change means like where is it going up or down the most. And kind of looking at the graph, I'm thinking that it's going to go right here, you know, because we jumped from basically 25 up to 45. So we increased by 20 that year. So from 10 to 11, correct answer there should be D. All right, moving right along. Going down to number 2. We have functions. We have a little table going here. So let's kind of see what we got. Some of the values of the linear function are shown in the table above. Which of the following defines f? So a couple different ways you can kind of do this. Now they try to trick you here by looking at the table, and I'm noticing it's going up by 8 every single time. However, over here on the right side, the x's are going up by 2. So if you kind of focus on the change in y versus the change in x, so I'm going to use a Greek letter for short, but delta y over delta x, you're changing by 8 every time x changes by 2, all right, which is basically slope. So our slope here is 4. So I know the correct answer is C. Another way I could do this, there's a few different ways. Another way I could do it is I could actually fill in those middle gaps. So I could kind of say, well, you know, it's going up to 2. That would be halfway between 5 and 13, which is 4 more, so that would be 9. 4 would be halfway, so that would be 17. And then you could work backwards and go back and get 0. So 4 less than 5 would be at 1. And that right there is an important point because that's the y-intercept. Remember, the y-intercept is wherever you cross the y-axis at x equals 0. So that would also have given you this key feature, the 1 there. Now, the other way you could have did is you could have just plugged these numbers in. That might have been a fast way to do it. Just be careful, because if you plug this first value into here, it would be true. You know, 2 times 1 plus 3, it does equal 5, so it works. However, when you try this one in that equation, it kind of falls apart, because you have 2 times 3 plus 3. Well, that comes out to be 6 plus 3 is 9, not 13. So you would have had to went a little bit further to plug it in. But that's kind of the long way to do it. I like the slope method. All right, moving right along. Let's go check out number 3. To make chocolate muffins, a baker needs 2.5 ounces of chocolate for each muffin. How many pounds of chocolate? So you see they switch units on us there. So this is kind of a rate problem or a ratio problem. So let's just do this. We need 2.5 ounces for every 1 muffin. How many pounds are we going to need to make 48 muffins? Well, first let's just figure out the ounces. So to make 48 muffins, and there's other ways to do this, but I kind of like to set it up. 2.5 ounces for 1 muffin. How many ounces for 48 muffins? And whenever you want to solve a proportion like this, you can cross multiply. So 1 times x is x. 2.5 times 48 would be 96 plus another 24. So what's that, 120? So we need 120 ounces to make 48 muffins. But we know that 1 pound is 16 ounces. 1 lb is 16 ounces. So how many pounds is 120 ounces? And again, there's different ways to do this, but I'm going to just kind of stick with cross multiplying. So you're going to get 16x equals 120. Divide both sides by 16, which you may have just kind of saw. We were supposed to do that anyway. And 16 goes in there, I believe, looks like 7.5 times. So the correct answer there is going to be A. Now there's another way to do it with dimensional analysis. So maybe I could show you that one. So kind of doing the canceling units method. you can kind of set up this way, and this way I'm a little shaky because I'm not a science teacher, I'm a math teacher, so a lot of times I don't do it like this, but we'll give it a shot. So it says I have 2.5 ounces for every 1 muffin, so that's definitely a rate that's in there. We need to bring pounds in, and we need to know how many pounds. So what I could do here is, if I want to cancel ounces, I'm going to find a conversion that has ounces on the bottom, because I can cancel out a unit when it's one's on top, one's on bottom. So our conversion they give us right here, 1 pound is 16 ounces. So we've kind of wiped out that clue. Then the last thing we need to do is we need 48 muffins. And since our final answer is just pounds, I need to get rid of that muffin unit. So I'm going to do 48 muffins. And somebody feel free to correct me later if there's a better way to do this canceling units, but I think this is how it goes. And so now I can basically cancel out ounces with ounces, muffins with muffins, and I end up with pounds. And it's pretty much the same thing that we did before. We're just multiplying all these top numbers. So we get 120, and we have our pounds still on top. And then on the bottom, 1 times 16 times 1 is 16, and dividing that out, we get 7.5 pounds. So it's pretty much the same math, just packaged a little bit differently. All right, number 4, it looks like we have a linear equation that, first it looks like we need to solve it, but actually, the more practice tests you do, the more tricks you see. And I noticed that they give me an equation here with this c plus d, and then they want to know what is the value of c plus d. So let's just kind of think about this. 3 times the quantity c plus d equals 5. And if I want to isolate, or I want to get c plus d all by itself, all I need to do is I need to divide both sides by 3. And that's going to leave me with c plus d equals 5/3. So the correct answer there is B. You don't have to distribute and do a bunch of other work. Always kind of peek over and see what you're after, because oftentimes it's a structure or a piece of the one on the left, and you don't have to break it down into tiny pieces. All right, number 5 here. The weight of an object on Venus is 9/10 of the weight on Earth. So you have Venus is 9/10 of the weight on Earth. Then you also have Jupiter is 23/10 of the weight on Earth. If an object weighs 100 pounds, how many more pounds? So this is kind of the key here. It's going to be a subtraction problem. How many more pounds does it weigh on Jupiter than Venus? So it says if you're 100 pounds on Earth, so we know what E is. So we have V equals 9/10 times 100. So basically I can just kind of cross that out and I get 90. You also could do decimals if you'd like. If you want to change 9/10 to a decimal, that would be 0.9 times 100. Either way. And then for Jupiter, this would be 23/10 times 100. So basically canceling those off, I have 230. Again, if you like decimals, you could actually divide that out in your calculator and get 2.3 times 100. So now I have Jupiter, I have Venus, and Jupiter take away Venus looks like 140 pounds. So you'll be 140 more pounds on Jupiter than you will on Venus. All right, number 6, an online bookstore sells novels and magazines. Each novel sells for $4. Each magazine sells for $1. Sadie purchased a total of 11. Combined price $20. So you could plug it in. I'm going to show you like the traditional way, actually setting up a system. So right away I see I have 2 different items. I have novels for $4, magazines for $1. And then we have a total price of $20. So I'm going to set up my first equation involving the money. So $4 times every novel plus $1 times every magazine equals $20. And in a lot of my systems of equations problems, I kind of set up a money equation. Then I have a quantity equation. So this one just deals with how many there are. It says we have a total of 11, but we don't know how many of each. So we just have novels plus magazines equal 11. So solving this system of equations, it's kind of already set up to where I have matching coefficients. I'm always looking to get my coefficients, that's these numbers in front of the variables, to match. And so since I already have a match there with magazines, I'm just going to go ahead and I can either add or subtract the two rows. Right now it's set up nice to subtract because I will cancel out or eliminate magazines. So 4n minus 1n is 3n. The magazines cancel out. I get 0. And over here I get 9 because 20 minus 11 is 9. Divide both sides by 3. And I have the novels are 3. So it looks like 3 novels. If I needed magazines, I could plug that back in there. And I would have 3 plus m equals 11. So subtracting from both sides, I also find out there's 8 magazines. But they wanted novels. So the correct answer there is B. Another way to do that problem, if you just want to kind of use the answers and you're not good with systems of equations, is just start plugging and trying them. So if I try 2 novels, so that'd be 2 times $4, that would be $8. And if I spent 20 total and I take away the 8, well, that would mean I spent $12 on magazines. And since they're $1 a piece, that would be 12 magazines. So if I had 2 novels and 12 magazines, that would be a total of 14, which would violate this piece right here. So that's why I know it couldn't work. And I could keep on plugging it in. And when I try the next one, if I tried 3 novels, I would have 3 times $4, which is $12. Subtract that from my 20. So 20 take away 12. That would give me $8 left. And since it's $1 per novel, that would be 8 magazines, or $1 per magazine, which would give me 11. But I like the system of equations. I think it's fast and you can always get the right answer without having to try all the answers. All right, number 7. Downtown Business Association in a certain city plans to increase its membership by a total of N businesses per year. So we're increasing by the same number of businesses every single year. We started with B businesses at the beginning. Which function best models the total number of businesses Y X years from now? So since it's increasing by the same amount per year, I know that this is going to be a linear function, constant change. So that's going to wipe out these 2 exponentials. And then the key word kind of here is increase its membership. So let's kind of look at this. So we take the number of businesses and we're going to multiply that each year and plus whatever we started with. And that should give us our total Y. All right, so let's just go in here and kind of plug in the values. So our total is going to be the number of businesses, which is N, multiplied per year. And it says right here that X represents the years. And then what we started with is B. You know, if you're not sure, you could actually just kind of pick some numbers and see if it works. So let's just say that we start with 10 businesses. And then let's say we're going to increase by 5 per year. So if I make a little table here, let's just make a little XY table. And, you know, so at year 0, at time 0, we have 10 businesses to start. Well, then 1 year later, we're going to add 5 to it. So we're going to have 15. 2 years later, we're going to have 5 to it. We're going to have 20. 3 years, we're going to have 25. So I believe right here, this is the correct answer. And if we plug our numbers in here, all right, and I kind of just said we're going to increase 5 per year. So that's going to be our N number. So if we kind of plug this in, we have Y equals 5 per year. So you plug the year in there, plus how much we started with, which in our little case over here, we started, our B was 10. And then if we plug in any value here, it should match up with our chart. So for instance, like if I want to try 2 years, I plug that in. 10 plus 10 equals 20. So it checks out. If I want to do 3 years, I plug that in. I get 25. So it checks out. So the correct answer there is A. All right, number 8. Which of the following is an equivalent form of, and then they have a couple of expressions. So it looks like we have a couple things we need to do. The first thing we need to do is we have this binomial here that we need to expand and multiply it by itself by a power of 2. And then we're going to have to do some subtraction. So let's kind of do this first part. Let's just do the 1.5x minus 2.4. and then multiply it by itself, 1.5x minus 2.4. So you can use, if you use FOIL or double distribution, either way. So 1.5 times 1.5, that's 2.25x squared. 2.4 times 1.5, that is negative 3.6x. Here on the inside, we get the same thing, so we end up doubling that, negative 3.6x. And then we have the last times the last, which 2.4 times 2.4 is 5.76 positive. All right, so I'm going to clean this up a little bit. I'm going to combine some like terms here. So we have 2.25x squared minus 7.2x plus 5.76. And then now we have to do this second part, which whenever there's a minus parentheses, you need to pretend there's a negative 1 there. And you're just going to distribute that negative 1, which just changes the signs. So we need to subtract 5.2x squared, and then we need to add 6.4. And now I just have one big expression. I got to combine some like terms. So let's check out the x squareds. I have 2.25 and a negative 5.2. So that's going to give me a negative 2.95 x squared, which eliminates these two. I always kind of do parts of the problem and I go eliminate what I can. And then the minus 7.2x, there's no other like terms to go with him. And then I have this plus 576 plus 6.4 is going to give me a positive 12.16. So the correct answer here is C. Number 9, in the 1908 Olympic Games, the Olympic marathon was lengthened from 40 kilometers to 42. Of the following, which is closest to the increase in the distance of the Olympic marathon in miles? Then they give you a conversion there. So this is kind of a proportion problem. I like to set them up that way. So it looks like if we're going from 40 to 42, we increase by 2 kilometers. And now we need to figure out what that is in miles. So you can kind of do a little setup like this. So they give me a conversion that 1 mile is 1.6 kilometers. All right. So I have 1 mile is 1.6 kilometers. So how many miles is 2 kilometers? And basically I'm going to do a little cross multiplying here. I get 2 and I get 1.6x and divide both sides by 1.6, divide by 1.6. And let's see what we get here. 2 divided by 1.6 is 1.25 miles. So the correct answer there is B. There's other ways you could do it using conversions, kind of like in a science class, but I usually like to just stick with the proportions. All right, number 10, the density D of an object is found by dividing the mass by its volume. Which of the following equations gives the mass in terms of the other two variables? So this is basically manipulating an equation. We're not really solving for anything, but whenever they say this m in terms of, all right, so that basically means they want us to solve for m. They want us to figure out what m equals. Well, let's translate the first equation. The density is found by dividing the mass by the volume. So density is mass divided by volume. And we need to rearrange that, solving it for m. So to get m all by itself, the opposite of dividing by v would be to multiply by v. That would cancel these two out. But if I multiply by v on one side, I have to do it to the other. So our final answer is m equals dv, or vd, however you want to put it. Correct answer there is A. All right, number 11, we have an equation of a line. It says in the xy plane, the graph of which of the following is perpendicular to the equation above. So we got to kind of deal with perpendicular. The big thing you need to know on this problem is that if two lines are perpendicular, their slopes are going to be opposite reciprocals. Okay, so remember, a reciprocal is basically the flip of a number. So for instance, this is just an example, but if you have a slope of 2/3, his reciprocal is going to be 3/2. And they also have to be opposite, meaning that if one is positive, the other one has to be negative. If it turns out to be a whole number, for instance, like 5, you can just put a 1 under it, and then it's a little bit easier to flip, and then just change the sign. So these are slopes that would be perpendicular to each other. So let's kind of get after this problem. I need to find the slope of this line. So the easiest way is going to get it into y equals mx plus b form, which then you can see the slope really easy. Remember, the slope is m. So let's kind of rearrange this thing. I have negative 2x plus 3y equals 6. First thing I'm going to do is I'm going to add that 2x to both sides. And I end up with 3y equals, and I like to put the x term in the front just so it looks more in this format. My next move is I need to divide everybody by 3. So that gives me y equals 2/3 x plus 2. So these two are the same line. It's just written in a little bit better form because now I can see that the slope is 2/3. Now, I need to be perpendicular, so I need to change my slope. I need to have a slope, so this is a symbol for perpendicular. My slope needs to be the flip of that, the reciprocal, and I need to change the sign. So I need to have a slope of negative 3/2. So looking at these equations over here, on this very first one, if you resolve this and you kind of move things around, you're going to have 2y, move the 3x to the other side. And then if I divide by 2, I'm going to end up with y equals negative 3/2 x. This last part doesn't even matter because I now see his slope is what I needed to be. So the correct answer here is A. Now, just a little kind of pro tip on this one to make it a lot faster. In general, lines are in the form ax plus by equals c. This is called standard form. And when you rearrange them and you move the x term to the other side, you're going to get this. And then when you divide by the b term, you're going to see that the slope is always negative a over b. So it makes it really fast if you know that trick to find the slope. So for instance, when I just look at this one, this is the a number, negative 2, and the b number is 3. So if I do negative a over b, that's going to come out to be negative 2 over 3, which is just 2/3. So it kind of saves you from doing all that. So when I look at these answers, if I just want to run through them real quick, opposite of a over b. So this line right here has a slope of negative 1/3. Opposite of a over b, that has a slope of negative 1/2. This one would be opposite of a over b, slope of negative 3/4. Opposite of a over b. You can just get the slopes much faster when you think about it in terms of a and b. So big takeaway is the slope is negative a over b. All right, number 12. Looks like we have a system of equations because I see 2 equations there. Has a solution of x, y, and we basically are only trying to figure out what is the value of x. So you always kind of know what you're looking for. So let's kind of get after this. I notice that the first equation does not have an x in it. So I'm going to solve that and actually find out what y is. So to figure out what y is, I'm going to multiply by the reciprocal of 1/2, which is 2, to both sides, because 2 times 1/2 cancels out. And I'm going to get y equals 8. So now that I have y equals 8, I can substitute that into my other equation. I can take this 8 and I can substitute it right here. So x minus 1/2 times 8 instead of y equals 2. And x minus half of 8 is 4, which equals 2. Then I add the 4 to both sides, and I get x equals 6. So the correct answer here is D. Now there might have been another way. I know some people like to clear fractions, so I'll show you that way. To clear fractions, you just multiply everybody by the denominator. So I could multiply this whole row by 2, and we get y equals 8. And then I can multiply all of this by 2, and I get 2x minus y equals 4. Same idea now. I'm basically just going to grab this 8 and put it in right here. And I get 2x minus 8 is 4. Add 8 to both sides, and then divide by 2. And again, I get x equals 6. So just another method using clearing fractions. All right, number 13, we got, looks like a system of inequalities. Which of the following order pairs satisfies the system above? So I'm going to show you two ways. I'm going to first show you a really fast way that you got to have a little bit more knowledge about graphing. And then I'll show you just a way where you can plug in points. So here's the really fast way. I'm going to draw a coordinate grid. And I know from looking at this first one, it's in slope-intercept form. The number in front of the x is the slope, and the number at the back is the y-intercept. So let me just get a couple points on here. 1, 2, 3, 4, 5. I wish the SAT would give us a grid on some of these problems, but they don't. So here we go. So I'm crossing at a positive 1. So right there. And then my slope is 3, which means I go up 3 over 1. So up 3 over 1, which is going to put me right here. And I'll go the other way, down 3 over 1. And I'm going to draw a line. Actually, because this has an equal to, it's solid. And then the one thing that you need to know is, since it's less than, since this one is y less than, I want to shade below on the x-axis. So I'm going to kind of come in and I'm going to shade everything on the side where the x-axis goes low, or the y-axis goes lower. So basically, all of this stuff here is going to get shaded, all right, because you're below the y-axis. Now on this other one, I'm going to go ahead and I'm going to rewrite this in slope-intercept form. So I'm going to move the x to the other side and make it negative. And then I need to divide everybody by a -1 or multiply everybody by a -1. Doesn't really matter. And one thing you got to remember is you do have to flip the sign when you divide or multiply by a negative. And so now I have this line. So this one, I can see my y-intercept is at positive, or is at -1. And then there's no number in front, so that means the slope is just 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. And your line's going to kind of look something like that. And again, since it's less than, I need to shade below. So shading below is going to be shading all of this part. And basically the solution to the system is the place that got double shaded. So looking on here, the place that got double shaded would be everything from here and here. So I need to pick a point in this region over here. So looking at that, if we go through our points, -2, -1, well that would be actually right where they cross, so it's not you. -1, 3, well that would be up here. You're a solution to nobody. 1, 5, over 1, up 5, that's right on the boundary line. 2, -1, right 2, down 1. That's a spot that's in the solution zone. So the correct answer here is D. Now I talked a lot through that, but if you know what you're doing, you could sketch that pretty quick. The other way to do this is simply take all of these x's and y's and plug them in. I have a really strong feeling that whenever you decide to plug numbers in, I always start from the bottom, work my way up, because it seems to me I see a lot of problems where the answer is D when you can plug in answers, and I think it's because they want you to waste a lot of time. So I'll just verify that this works. If I go up in the first equation, instead of putting y, I'm going to put -1 less than or equal to 3 times x plus 1. And then I got to ask myself, is that true or not? Is -1 less than or equal to 7? All right? Yes, that's true. So then we need to try the bottom equation, doing the same thing. So I'm going to plug the x and y into that one. And 2 take away a -1, is that greater than 1? Well, 2 minus a -1 is really 3. And 3 is greater than 1. So this is a yes. So this point right here worked in both of those. If you try everybody else, those points wouldn't work for both of them. But that could take you a long time if you started with A, B, C, and then finally got to D. So you kind of have to know which way you're good with. All right, number 14. Looks like we have a table data problem here. So looks like we have surgeons on the left, whether they teach or whether they perform research. And my totals, this is the total for this row going across. All right, so if you add those two up, you should get 414. If you add these going to the right, you should get 193. And then the grand total is 607. This is usually a really important number of the table because that is the grand total of everybody. All right. And the columns also add up going down. If you come this way, and you add those two numbers, you're going to get 377. Coming down this way, you're going to get 230. So you can add in both directions, horizontally and vertically. All right, in a survey, 607 surgeons indicate their major profession. If one of the surgeons is selected at random, all right, one of the surgeons selected at random, so that means out of 607, put all their names in a hat. Which of the following is closest to the probability or the chance that the surgeon is going to be orthopedic, whose indicated activity is research? All right, so let's just double check this real quick. So we need, out of all the orthopedics, okay, we want the one whose activity is research, which is this block right here. So that's going to be our top number. So 74 out of the 607 are orthopedics who perform research. And when you divide that out, you roughly get 0.122. So the correct answer here is A. Number 15, a polling agency surveyed 1,000 adults selected at random from a large city, asked them about their air quality, if they were satisfied. Of those surveyed, 78% said they were satisfied. Based on the survey, what can we conclude? So this is a statistics problem. Usually they're checking about validity or can you come to a certain conclusion. So let's go through and see which of these three, if any, are true. So number one, of all, that's a very powerful word there, of all adults in the city, 78% are satisfied. We don't know that. Of the survey, 78% was satisfied, but we don't know that exactly 78% in the city. So number one is out. So if we look down here, that's going to wipe out C and that's going to wipe out D. So now we just have to check number two. If another 1,000 adults were selected at random, 78% of those are going to report they're satisfied. We don't know that for sure. Maybe the first 1,000 just happened to be people who were more satisfied or less satisfied. So we cannot conclude that from the survey. So that wipes out B, which leaves the correct answer must be A. All right, number 16. This is one of those multi-problem questions. So we're going to have this chart and we're going to apply it to 16, 17, and 18. So it looks like we have species of tree here in this column, and then we have some sort of a growth factor. Some trees, looks like maybe the red maple grows faster than the cottonwood. Shagbark hickory looks like it probably grows the fastest. So one method of calculating the approximate age, so there's a way to get the age, is multiply the diameter in inches by the growth factor. So it looks like if we go the diameter times the growth factor, that will give us the age. And we have 8 trees there, so let's get after it. According to the information on the table, what is the age? So we're trying to figure out what is the age of an American elm. So American elm is right here. So we have a growth factor of 4.0. And the diameter is 12 inches. So 12 times 4, it looks like this one is 48 years. Correct answer is D. All right, same idea, number 17. Same chart, same information. So this time we have a scatter plot. So we still have our formula. Let's kind of write that down. Age is the diameter times the growth factor. Kind of make that a little bit more simple. Scatter plot gives the tree diameter plotted against an age for 26 trees of a single species. The growth factor is closest to that of which of the following? So which of these could it actually be? A couple different ways to look about this. We could just put some numbers in. I could pick, a couple points and check them. So like maybe this point right here is at 11 inches and it's roughly at, 84, 85 years old. And so we could just plug these two into the equation and see what we get. So an 84-year-old tree that has a diameter of 11 inches, what would be the growth factor? So I'm going to divide these two. Divide by 11, divide by 11. And G equals, I don't know, that goes in there 7 with 7 left over. So 7 and 7/11. So the only growth factor close to that is right here. It's not perfect just because I kind of guessed on a point. But looks like the shagbark hickory is the only one that would fit the data. And it looks like if I picked other points, it would kind of fit as well. And basically what you're looking at is this slope is actually the growth factor. Okay, it's what it's changing by every single year. So you could have kind of picked a couple points, you know, on this line and maybe go from like 12 to 16 and just kind of checked out the slope. You know, if you go from 80 to 120, that's a growth of like 40, you know, going from here to here in height. And then your run, you know, going from somewhere here 12 to 16, you know, it's not perfect. You know, 40 over 4, which is 10. But still, he's the only guy that would be even close. But, you know, you could have picked different points, which would have drastically changed the slope. So it's kind of hard with the scatter plot. So I think plugging the points would have been the best move. All right, number 18, last and final question off of this chart. It says, if a white birch and a pin oak each now have a diameter of 1 foot, okay, which is 12 inches, which of the following will be closest to the difference? So I know I'm going to be doing some subtraction here in a little bit. The difference of their diameters 10 years from now. All right, well, there's a lot going on. So let me kind of try to digest this one bit at a time. So we have a white birch has a diameter of 1 foot right now. So let's kind of check that out. So the white birch is right here, diameter of 1 foot. So right now we have this formula, age equals diameter times the growth factor. And the age we don't really know yet. We do know the diameter is 12 inches and the growth factor is 5. So it looks like this pin oak is 60, or this white birch is 60 years old. So we're going to call this the white birch data. All right. And then in red, I'm going to do the other one, the pin oak. So the pin oak is here. So pretty similar, except for, you know, when we do age equals diameter times growth factor. This is the pin oak side. The diameter is 12. The growth factor is 3. So that one is 36 years old. So all of this right here is now. Okay. Well, then the question kind of changes and it says, which of the following will be closest to the difference 10 years from now? So this is kind of key. 10 years from now. So let's use this information. Well, 10 years from now, the white birch is going to be 70 years old if we add 10 years. So 70 years old, the growth factor is still 5, but we're missing the diameter. All right, so we need to solve for this. We need to solve for the diameter. We divide that side by 5, divide by 5, and it looks like the diameter is going to be 14 inches. All right, and if I come over here to the pin oak, 10 years from now, he will be 46. Okay, we do not know the diameter, but we do know the growth factor. And we divide both sides by 3. Divide by 3. And we are going to get that the diameter is, 3 goes in there, 1, 5, and 1/3. Okay? So now, ultimate question is, what is the difference? We want to know the difference of their diameters. So when I subtract those two numbers, 15 and 1/3, take away 14 is 1 and 1/3, which, you know, is 1.3 repeating. So I guess I'm going to have to pick C would be the correct answer for this one. Usually they don't put the answers that close together. You know, these are jammed really tight, but pretty confident the answer is C. Number 19, finally get a hold of a geometry problem. Looks like we're focusing on the properties of triangles. So in ABC above, what is the length of side AD? So ultimate question is, how long is AD? So let's kind of go through. I think there's a lot of ways I could tackle this problem. First of all, I know that the degrees in a triangle always add up to 180. So this little box here means 90. So 90 plus 60 is 150. Subtract that from 180. That means I have 30 degrees up top. And since this forms a straight line down here at the bottom, that's got to be 90. So basically, these two triangles are flips of each other. Well, right now I noticed that this angle is 60, this angle is 60, and this top angle, when I add those two 30s up, are 60. So whenever you have three angles that are 60 degrees, that means this is an equilateral triangle. All three angles are equal, so all three sides must be equal. And since that green side there, AD, is exactly halfway, it looks like the correct answer here is going to be 6. All right, number 20. Looks like we have a physics problem, some sort of a graph here, so let's jump into it. Says the figure on the left shows a wheel with a mark on the rim, so right here is the mark on the rim. The wheel is rolling on the ground at a constant rate, all right, so it's not changing speeds from a starting to an end point. The graph on the right is which one could be a function of the time from the wheel began to roll. So let's check out part A, the speed at which the wheel is rolling. Well, they said that the speed was constant. So if I was going to graph the speed, it would just be straight. It wouldn't be changing. It'd be a constant speed. This graph right here is showing that the speed would be going, fast and then down to 0 and then fast and down to 0. So I know that it can't be A. So let's kind of wipe that one out. Next one, the distance of the wheel from the starting point. All right. Well, if this is the starting point right here on the ground and I keep rolling the wheel, eventually it's going to be way the heck over here somewhere. So the distance is going to be starting from 0 and getting further and further and further away at a constant rate. So I know that B cannot be the correct answer. So I'm going to get rid of that one. C, the distance of the mark on the rim from the center of the wheel. Well, regardless if the wheel is rolling or not, the distance from the center to the mark stays the same. Whatever that distance is, if it's 3 or 4 inches. So that's also going to be a graph that just remains constant. The distance stays fixed. So C is out of there. So hopefully D is the right answer. Let's check it out. The distance of the mark on the rim from the ground. And that makes sense because right here it's at its highest point. And then as the wheel turns, that mark is going to go all the way down until it touches the ground. Then it's going to start back up and get to the highest point of the wheel, back to the lowest point of the wheel, and so on and so forth. So the correct answer here is D. All right, number 21. Looks like we have an equation. No numbers, A, B's, and C's. I don't really like these ones. These ones, a lot of times, you just got to pick numbers and you got to plug them in. So that's what I'm going to do on this one. In the equation above, if A is negative, so, I'm going to try, I don't know, maybe I'll try -2. And so that's my A. And if B is positive, so B's got to be positive, and I'll pick a small number like +3, which of the following must be true? So let's kind of plug this in. So if we do A minus B all divided by A, let's see what we get. Well, that comes out to be -2 take away 3. That's plus a negative, so that's a -5 divided by a -2. Negative divided by a negative is a positive. So I'm getting 2.5. So 2.5 is not, well, it could be this one. It is greater than 1. It's not equal to 1. It's not equal to -1. And it's not less than -1. So I believe the correct answer here has to be A. Sometimes you might get 2 right answers, and you may have to play and change your numbers a little bit. So somebody else might have said, hey, I'm going to do A is -1 and B is +1. Let's just say that you did that. You would get a -1 minus a +1 all divided by a -1, which that's a -2 divided by a -1, which is +2. And that one would still work too. Sometimes, though, you do get 2 right answers, and you got to just try some more numbers until you get it down to 1. All right, number 22. In State X, Mr. Camp's 8th grade class consisting of 26 students. So I know I have 26 students in a class were surveyed, and 34.6% said they had at least 2 siblings. Okay, so at least 2 means you have 3 or more siblings. The average 8th grade class is 26, so that's the average class size, so he's an average class. If the students in his class are representative of the students in the state's 8th grade classes, so that means we can use the 34.6% and we can apply it to a bigger population. And there are 1,800 8th grade classes. All right, so there's 1,800 classes. Which of the following best estimates the number of 8th grade students who have fewer than 2 siblings? All right, so we got to kind of be careful here. So the first thing I want you to recognize is, in the survey, 34.6% had 3 or more. If we want to look at fewer than 2, all right, that we're going to have to do the flip side of this. We're going to actually have to subtract from 100%, and we're going to get 65.4%, all right, right there, have fewer than 2. And it looks like I might have messed up here on the top number because it says that they have at least 2. So that doesn't mean 3 or more. At least 2 means 2 or more. I was kind of worried there that I was missing somebody. All right. Well, let's check it out. So we're trying to find the total number. Look at my answers. I always cheat down. Look at those. Those are big numbers. So I need to kind of use this 1,800. There's 1,800 classes. Okay. 1,800 classes times 26 kids per class, because that was the average. So when I crank that number out on the calculator, I get 1,800 times 26. So there's 46,800 total students in the 8th grade, all right, in State X. So that's the total. And if I want to know how many fewer, well, 65.4% of that. So let's do this. 65.4% of, so the shortcut way to do this is you multiply, and we need to change this percent to a decimal, so I'm going to move it 2 to the left. I'm going to go 0.654 times 46,800, so times 0.654, because the other number was still in my calculator. I'm getting about 30607.2, and looks like the correct answer here is C. Now I bet they want you to screw up and they want you to pick A, because if you picked A, you were using this number for 2 or more, but they kind of switched it down here at the bottom. So be very careful. They tend to do stuff like that to try to trip you up. All right, number 23 and 24. Looks like we have a big graph here, and it's going to go for 2 different problems. So let's check it out. 23 says the relationship between the monthly rental price R, so this is my R, and the property's purchase price P, in thousands of dollars, so that's going to come into play here in a second, can be represented by a linear function. Which of the following functions represents this relationship? So we need to construct a model to kind of predict purchase price or rental price. So I just got to try some numbers here and see which one works. So for part A, I'm going to have 2.5p, so 2.5, and let's just pick one of the numbers over here. This one's pretty small, so I'm going to use that because it's smaller numbers. P was in thousands, so instead of writing in 70,000, I'm just going to put 70, all right? And then I'm going to subtract 870, and let's see what the rental price is. So 2.5 times 70, well, that's going to be only 175, take away 870. That's going to give me a negative number. So I know that A can't work. So let's try B here. Let's try 5 times the purchase price plus 165. Well, that's 350 plus 165. So that comes out to be what, about 515? Hey, 515, so we have a match. So I believe the correct answer here is B. Now, if I had time on the test, I might go back and try some of the other ones. But if time is an issue, right now I got a lock, I'm going to move on. All right, number 24, second part of this question. So it says, Townsend Realty purchased the Glenview property and received 40% discount off the price, additional 20% off the price for purchasing in cash. So they had two discounts. So first one was 40% off, second one was 20% off. Which best approximate the original, got cut off a little bit here, the original dollars of the Glenview property. So let me show you how to do these multiple discounts at once. The big thing is you cannot add those two together and say 60% off. All right, it's never easy to do like that because you're taking percents off of two different numbers. So let me show you the fastest way to do this. You always have some sort of a starting amount, all right? And then you are going to apply some sort of discount. And whatever the discount is, think about it as if it's 40% off, that means you're paying 60% of full price. So in this parenthesis, I'm going to do 1 minus 60%, which I write as a decimal. Actually, check that. 1 minus 40%. So there's going to be a 0.60 because I'm paying 60% of full price. And then after that calculation's done, I'm then taking away 20%, so minus 0.20. So I'm now paying 80% of that price. And then this ends up being my final price. All right, so in this question, they want to know what was the original price, what was the beginning part. So I don't know the starting amount, but I do know there was 40% taken off, and then I do know there was 20% taken off, and then the final price I can get from the chart over here. The final price was $140,000. This is the easiest way to do these multiple percentage problems. So I'm going to go through and I'm going to multiply this out. This is going to be 0.48x equals 140,000. And now to solve for x, or to solve for the original amount, just to divide both sides by 0.48. So I'm going to pop this into my calculator. 140,000 divided by 0.48. Getting somewhere in the neighborhood of 29,1666. So that looks like it's going to be the correct answer, is B. So if you want more explanation on that one, you're going to have to watch one of my percentage tutorials, because this is a really nice, fast, easy way to do it. And a lot of times the SAT sets their answers up with this type of formatting. And sometimes you don't even need to get the final answer. You just need the setup. All right, number 25. Psychologists set up an experiment, studied the tendency of a person to select the first item when presented a series of items. Had 300 people. We're looking at a set of 5 pictures. All right, so we have 5 pictures here. And 300 people looking at them. Each person was asked to choose the most appealing picture. Out of the first 150, we had 36 out of 150 chose picture number 1. Then among the remaining 150, so out of the next 150, we had P people chose picture number 1. So our grand total is we have P plus 36 people chose picture number 1. And it says if more than 20% of all the participants chose that. So these people right here are more than 20% of all the participants. So this is just a little short way to find 20% of 300. So looking down here at the bottom, which are the best inequalities? It looks like the correct answer here is going to be D. All right, number 26. Looks like we got a little geometry problem. You don't see those very often, but surface area of a cube is 6 times a over 4 squared, where a is a positive constant, positive number, which the following gives the perimeter. So our ultimate answer is we need to find the perimeter of one face of a cube. So I'm going to first draw a cube. A cube is basically just a square that has all All sides are the same. So we kind of have something like this going on. And the surface area, well, the surface area is you find the area of every single face of every single side and you add them all together. And there's actually 6 faces here. All right, so we have a top, we have a bottom, we have a left, we have a right, and we have a front, and we have a back. So there's 6 faces. So to find the total surface area, you do 6 times the area of each individual square. All right, so let's maybe focus on this square right here. And once we find the area of that square, we multiply it by 6, and that gives us the surface area. Well, when we look at this, it's set up, there's my 6. So I have 6 of those. And this expression right here represents the area of that square. So remember, whenever you want to find the area of a square, whatever, say this side is x, you just basically go length times width or base times height. X times x is x squared. But they actually told me what x is. They're saying it's a over 4 squared. So I'm going to replace this. I'm going to say, all right, this dimension is a over 4 times a over 4. Because when I multiply length times width, I'm going to get a over 4 squared, and then I times it by 6 of them. Well, now it's pretty easy to find the perimeter, because remember, the perimeter is you simply add up the distance around the square. So, we're basically just adding up a plus 4 over a plus 4, a plus 4, a plus 4, or it would have been easier to just do 4 times a over 4. Either way, final answer comes out to just be A, so B. Number 27, looks like we got a statistics problem, averages. So the mean score, so remember the mean basically is just the average. You add up how many you have and divide by that number. So the mean score of 8 players in a basketball game was 14.5 points. So let's think about this. You're basically adding up, let me see, it would be 1, 2, 3, 4, 5, 6, 7, 8. So you're adding up 8 people's scores, and you divide by 8, and the average would come out to be 14.5. So what you can do right now, I don't even know what these scores are, but I know what the total has to be. All right, if I just kind of focus on the total, I can kind of work backwards here. So the total of all 8 people divided by 8 gives me an answer of 14.5. So to find that total, I'm going to multiply both sides by 8. Multiply by 8, and I find out that the total score was, what's that, 80, 32 is 112 plus 4, 116. So my total is going to be 116. All right, so that's what all 8 people added up to. And if you do the math and check it out, it should come out to be 14.5. Now, it says if the highest score is removed, then the average of the 7 players is going to become 12. So we're going to kind of repeat this process and say, well, if we take out the highest scoring person, the average is now 12. So let's work backwards. 12 times 7 is 84. So we now can check out and see the difference. With only 7 people, the total was 84. With 8 people, it was 116. So we need to subtract those 2 numbers to see what the high score was. So the correct answer there is C. So that's a pretty valuable skill of working backwards, is if you know how many players there are, how many people there are, and you know the average, you can multiply backwards to get the total. And that's the key to a lot of these type of problems. Number 28, looks like we're looking at a graph of functions. It's a line, so graphs of linear functions. So I probably know that at some point I'm going to be looking at slope-intercept form, which is always helpful. Y equals mx plus b. Remember, what's in front of the x is the slope, and then this back number here is where you cross the y-axis or the y-intercept. So let's check it out. It says the graph of a linear function f is shown above. So I'm going to just kind of color code this. So this is our f line. And the slope of the graph of a linear function g, so that's not on the graph, that's a new one, g, is 4 times the slope of f. So g has a slope that's equal to 4 times the f slope. If g goes through the point 0, -4, so let's just we know that point, 0, -4, it's 1, 2, 3, it'd be right down around here somewhere, if I kind of extend that down. So at what value of g of 9? So ultimately they want to know, and this goes way off the grid, but this is g of 1, g of 2, g of 3, g of 4, g of 5. So basically they want to know when x equals 9, what does y equal for this new g function? All right, well, before I can do anything, let's deal with this clue right here that says the slope of g is 4 times f slope. Well, to find f slope, remember slope is just rise over run. So we're rising 1 block, we're running 2. So f has a slope of 1/2. So if I'm trying to find g slope, g has a slope of 4 times 1/2, all right, or 2. So g has a slope of 2. Well, now we know a couple things about it. If I kind of go back up here and I think about slope-intercept form, we now have our 2 key ingredients. Our slope is 2, and our y-intercept point is at -4. So now I have an equation for g. All right, g of x is kind of just the same thing as y. So g of x has to be 2x minus 4. And they want to know what is g of 9. So I'm just going to stick 9 in for x. 2 times 9, subtract 4. So that's 18, take away 4, which gives me a final answer of 14. So very important that you understand the key features of the graph, that you can find slope, you can find the y-intercept, and then use those to find any other point on the line or on the function. All right, number 29. This one's pretty tough. The equation defines a circle in the xy plane. What are the coordinates of the center of a circle? So let me just quickly kind of go over in general what you need to know about circles. So generally circles have this type of form. Actually, I screwed that up a little bit. It would be x minus h squared plus y minus k squared equals the radius squared. And basically what you need to know is that h and k represent the center and that r is the radius. So let me just make one up for pretend. Let's say it said x minus 4 squared plus y plus 3 squared equals 16. If you wanted to graph that on the grid, you can basically use these coordinates here, and since it's in x minus form and h is just what goes here, it's kind of like the opposite of what you would think. This first x coordinate of the center is just 4, because remember the form is x minus, so it's just whatever's sitting here is your x term. And then your y is actually going to be -3, because in order for this to happen, it would be y minus a -3 would be my k to make it be +3. So just think opposites when you're trying to figure out the center point there. So that would be my center point. And then since this is r squared, I would take the square root of it, and I find out the radius is 4. So I could put it on my grid, and I could say 1, 2, 3, 4, 1, 2, 3. So there's my center. And then I just go out a radius of 4 in every direction. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then down. And I could sketch a nice little circle right there. So that's kind of the basics of a circle. Now this kind of takes that and takes it on steroids basically, because I don't have it in this form. I don't have it in the x something form. So I'm going to need to do what's called completing the square. This is a rough problem. So here we go. So basically I have x squared plus 20x, and to complete this square I'm going to leave room to put something right here. And then we're going to do the y part. I have y squared plus 16y plus, and I'm going to leave a box right there, equals, and then since I'm just adding 2 boxes onto the left-hand side, I'm going to need to add those 2 boxes back to the right-hand side to keep everything balanced. Kind of running out of room here. So let's get after this. So how you complete the square. Basically, you take this number in front of x, you cut it in half, and then you square it. All right? So you cut it in half, and then you square it, which 10 squared is going to be 100. And then over here in the red, I'm going to cut this number in half, and then I'm going to square it, and I get 64. And basically what I just created was I wanted to make sure that I forced this thing to be a perfect square that was nice and factorable. So I have that, and then since I got my boxes, I have a 100 that I need to add, and then I have a 64 that I need to add. And so over here on the right hand side, I'm going to get negative 20 plus 100, that's 80, plus 64, so it looks like 144, which is perfect. So now I'm looking at this thing and it's in the right equation for a circle. I can now get my center point. Okay, the opposite of positive 10 is negative 10. The opposite of negative 8 or positive 8 is negative 8. And this thing has a radius of, remember this was r squared, so it has a radius of 12. So now I go back to the question and it says, what are the coordinates of the center of the circle? Correct answer there is negative 10, negative 8. Now this one took me a long time the first time I looked at it. I knew I had to somehow get it into circle form, which is basically where you have the x with these parentheses. And completing the square is pretty much the only way I found to do it. If you have a better way, I'd like to see it in the comments. All right, got number 30 here. Scroll down a little bit just so we can see it. So number 30, y equals x squared minus a, so we have a quadratic. In the equation above, a is positive, so a is a positive number, and the graph is a parabola. So remember, a parabola is just something that kind of looks like this. It looks like a bowl. Which I find is an equivalent form. So we need to manipulate this equation. We need to move it around, and it looks like we need to factor it. So the first thing that jumps out at me is I notice that this is what's called a difference of squares. Let me just give you a number just to make this a little easier. Let's just call this 16. I'll show you why I picked 16, because when I factor this thing out, the way to get this to work is I'm kind of doing like FOIL backwards, but x times x gives me my x squared. And what happens on the difference of squares is you need to find the two numbers that multiply to make that negative 16, but when they add, they're going to make 0. All right? So this would be a positive 4 and a negative 4. And if you double check it and you actually worked it out, you know, you get x squared, you get minus 4x, distribute again, you get positive 4x, distribute again, you get the negative 16. And you'll notice that these middle terms cancel out, and that's how you end up with an x squared and then just a constant, and you lose your x term. So if we do another one that would work out nice would be y equals x squared minus 9. You know, that one would be x plus 3 and x minus 3. Again, my middle terms are going to cancel out, and I'm going to just end up with the x squared minus 9. Well, I'm trying to find a relationship because I'm looking here, they have an a, but then when you look at your answers, I don't think it was the same number, because if you look at mine, our 16, which is the a, became 4, and my 9 became 3. So the relationship between what's up top and what's in the parentheses are, down here is the square root of 9, or the square root of 16. So in this problem, it's going to be the square root of a. So no matter what a you put in this slot, these numbers here at the back are going to have to be the square root of a. That's just how you factor the difference of squares. All right, number 31, horsepower and watts are units of measure of power. They are directly proportional. So I'm going to set up a proportion here on this one, such that 5 horsepower equals 3730 watts. So I like to set these up this way. 5 horsepower represents 3,730 watts. And when I set up a proportion, I have to make sure that I put horsepower on the top and watts on the bottom. So we need to figure out how much power in watts. So we don't know how many watts for 2 horsepower. And then whenever you want to solve a proportion, you can cross multiply. So I'm going to get 5x equals 2 times 3730. So 3730 doubled, 7460. And then we divide both sides by 5. And we end up with 1492. Then I always kind of want to double check and just make sure that that makes sense. So 5 horsepower was 3730. 2 was a little less than half of that. So 1492 is less than half. So that looks like it works out right. So correct answer, 1492. You don't have to put watts in there. There's nowhere to bubble that on the free response. So just 1492. Number 32, got a word problem here. It says that the painting The Starry Night by Vincent van Gogh is rectangular in shape. All right, so let me bust out a little rectangle here. Rectangular in shape with a height of 29 inches. So I'm going to put the height over here. That'll be my H. And a width of 36.25. So 36.25, that's my width. If a reproduction was made where each dimension, so that's what these guys are. This is just what they're referring to are the dimensions. All right, each dimension is 1/3 of the original dimension. So 1/3 basically means that we're going to divide by 3. We're going to shrink it down to 1/3 size. They want to know what is the height of the reproduction. So this was the original. The reproduction, we just need to divide that by 3. So the correct answer is 29/3. So when you grid that in, you need to do 2, 9/3. That would be how you bubble that in. Now, if you wanted to divide it out, which I wouldn't because it wastes time, but if you really wanted to, they would also accept 9.66. Rounded correctly, it would be 9.67. But they usually accept it when you truncate it or just chop it off, or they do it if you round it. But to me, this is the fastest, and I wouldn't even worry about the decimals. Number 33, looks like we got a little bit of geometry going on here. So one thing to see right away is note, figure is not drawn to scale. So a piece that looks longer than another may be shorter, and vice versa. So it says, on segment PS above, PQ equals RS. So this is really important. So this right here refers to the length or the distance from P to Q. So P to Q, I'm going to put a little congruency mark. PQ is the same length as RS. And then our final answer is, what is the length of PS? So PS actually represents the entire line. So we're trying to find the total length. So basically what I got to do is I got to figure out what the heck X is. So I'm going to use this idea right here. Since PQ equals RS, I'm going to set up an equation. That means that X minus 1 has to equal 3X minus 7, because those were the values for RS and for PQ. So I solve this out. I like to always attack the weakest variable, smallest variables first. So I subtract X from both sides. I get -1 equals 2X minus 7. Now that I've isolated X on the right, I'm going to do the opposite, add 7 to both sides. So I get 6 equals 2X. And then finally divide both sides by 2 and get X equals 3. Now, I bet there are some kids that put the answer 3 down and think they're done, but we're not done yet. We need to substitute that 3 in everywhere where you see an X. So I need to put it in here, I need to put it in here, and I need to put it in here to find the true measures. So let's do that. So 3 take away 1, well that's 2. X is just 3. And then 3 times 3 is 9, take away 7, which is 2. So now I can get the grand total. I just basically add up 2 plus 3 plus 2 for a length of 7. So final answer to this one is 7. All right, number 34. In the xy plane, the point 25 lies on the graph of the function f. F of x is k minus x squared, where k is a constant. I have kids all the time ask me, what is a constant? It's just a number that doesn't change. All right, so just think about a constant as a number. What is the value of k? All right, so big idea here. You don't really need this graph, and I'm not going to use it to solve it. But big idea is I have a graph, and then I have an equation here. And really, you can just think of f of x as y equals k minus x squared. And if you understand transformations, you'll know that x squared makes a parabola. And since there's a negative sign in front of x squared, it's going to open down. And k is just basically going to be a shift up somewhere. You know, none of this is really critical to this problem, but they're saying that some point 2, 5 is on the graph. All right, and this is just a rough, bad sketch, but that's the idea there. And we're trying to figure out what k is. I think it's a lot easier to just do this algebraically. Let's just rewrite this equation. So I'm going to rewrite y equals k minus x squared. And what I'm about to tell you right now is so important. When they say that the point lies on the graph, all right, that means that if you take this x and you take this y and you plug it in, it makes the equation true. All right, so I'm going to do that. I'm going to plug in the y. I don't know what k is. That's what I'm trying to figure out. And then I'm going to plug in the x, which is 2. And we have an equation that says 5 equals k minus 4. And we add 4 to both sides. And we figure out k equals 9. So my graph over here was way off. It was actually shifted up at a height of 9. But I think it's much easier to solve this one using algebra. All right, number 35. Got a little word problem here. It says a landscaper is designing a rectangular garden. So let me draw this rectangle out. And the length is 5 feet longer than the width. All right, and the area is going to be 104. Ultimate question is, I'm going to like to underline that, what will be the length? So we're trying to find the length here. Two ways you can do this. I'm going to show you algebra, and then I'm going to show you just kind of a guess and check method. So the deal is we have a clue. It says the length is 5 feet longer than the width. Now, they don't tell me anything about the width, so I'm going to call the width W. And instead of using L for length, it says the length is 5 feet longer than the width. So it's basically whatever the width is plus 5. And then ultimately the area inside is going to equal 104. So remember, how you find the area of a rectangle is you're going to multiply the length times the width. So I'm going to multiply these two together, and it needs to come out to be 104. So we work this thing out, and we get W squared, I'm just distributing here, W squared plus 5W equals 104. And this is a quadratic, and whenever I want to solve a quadratic, I want to get 0 on one side. So I'm going to minus 104 from both sides. And I get W squared plus 5W minus 104 equals 0. You could graph this if you had a graphing calculator. I'm going to just do an old school factoring method. So the deal is I need to find two numbers that can multiply to make negative 104. So they need to multiply to make negative 104, but then they need to add to make positive 5. All right. Well, that might be kind of challenging in itself. So let me figure out how I can make 104. Well, I can do 1 times 104. I could do 2 times 52. Will 3 go into 104? 3 won't go in there, so that one doesn't work. 4 goes in there. 2, 26. 4 and 26. But I'm still pretty far apart, so I got to keep going. 5 doesn't go in there. 6 doesn't go in there. 7 doesn't go in there. 8 goes in there. So we have 8 goes into 104, 1, 3. There's our combination. I can get a 5 out of that. So here we go. I needed to multiply to make negative number. I needed to add to make a positive. So my positive has to be bigger. So I believe I'm going to have W minus 8 and W plus 13. Now, I'm going to use what's called the zero product property. If something times something equals 0, either this expression has to equal 0 or this expression has to equal 0. And only one of these makes sense. You know, this expression is 0 when W equals 8. This expression is 0 when W equals negative 13, which doesn't make sense because you can't have a negative width. So I know now that the width is 8, but remember, we wanted the length. So I now need to find out the length. Well, it's 5 more. So the length is 13. So the correct answer here is 13. Now there was a lot of algebra there. I'm going to show you another way that a lot of my kids can solve it quicker than that, just by using a little guess and check method. So here's kind of another strategy. You can just start this out and say, hey, I have the width, I have the length, and I have the area. And I need to remember that this length is 5 more than the width. And you can just start trying some numbers, you know. Just if I started at 1, I wouldn't want to start at 1. But if I start at 1, if the width was 1, the length would be 6, because that's 5 more. But when your area would only be 1 times 6. So then I might jump to maybe 3. And I'd say, well, if the width is 3 and the length is 5 more than that, still way too small. So maybe I jump to 7. If the width is 7, 5 more than that would be 12. And now I'm up to 84. I'm getting close. And, you know, maybe you go too far and you say, well, the width is 9. The length is 5 more than that. And that's going to be 90 and 36, 126. Oh, man, that's too big. I got to back up. And you'd eventually settle in to the correct answer here. And to be honest, for most kids, that would be faster than doing it the traditional way. So you can always use guess and check. All right, number 36. Quick little crash course here on circles and what we're going to need for this problem. We're trying to find the measure of angle x. All right, so we're trying to figure out how many degrees that is. You can't always trust their pictures. But here's a big idea. If you have a circle, there's something called the arc measure. The arc measure is the measure of the arcs all the way around. So let's just say, for instance, you know, say we have a 90-degree angle right here at the center. All right. Well, this arc right here, and I'm not talking the length here, I'm talking the arc measure, is 90 degrees. Because a full circle, if you go all the way around, you know, if I come over here, you know, here's another 90, and then a half a circle is 180, and every single circle should add up to 360 degrees. Now, these angles that I had here, these are called central angles. All right? So a central angle, basically whatever the angle is, the arc is. So if you have a central angle and you learn that this is, you know, say 60 degrees, this arc measure is also 60 degrees. Now, the length will be determined by how big the radius is. But one that you need for this problem is there's another property or another theorem that if you have an angle that's on the circle, so let's say that the angle kind of cuts out and does something like this, all right? Well, there's another property. Whatever this angle right here is, let's just say that, I don't know, this one's maybe 50 degrees. The rule is that the arc that it intersects or intercepts out here is actually double. All right? So in general, whatever the angle is, the arc is going to be twice that size. That's only if, though, it's only if the vertex of the angle is on the circle, where up here the vertex was in the center, so they were equal. So I'm going to use that on this picture here. So apologize for the setup, but I think we need it. So what I'm going to do here, I can see that x should be the exact same as this arc here, because it's a central angle. This is right here in the middle. But I have a couple other clues that I can use here. So notice that if I focus my efforts right here on this little corner, and I'm going to go with a really fine line because it might get too many lines here. But if I'm coming all the way out like that, and this is 20 degrees, that means that this arc right here has to be double that. That has to be 40 degrees. And then if I kind of play the same game, and I kind of come across here, and here, then that means that since this was 20 degrees, this arc is going to be 20 degrees. All right, so I have a couple 20 degrees going on there for the arcs. And now, here's kind of the big thing. If you notice what we just did right here, actually, I don't know why I wrote that, not 20. I had to double it. Sorry about that. Is 40 degrees. If you notice what we have, and I'm going to draw this with really big letters, or a really big marker, I have a line cutting through here, and I have a line cutting through here. And now what we have we have a pair of vertical angles. This angle should be the exact same as that angle. They're what's called vertical angles in geometry, which means this length right here, which is 40 plus 40, or 80, should match this length over here. So final answer to this problem, which was a little bit tougher, is 80. All right, number 37, 38. We have Mrs. Simon's workday morning drive. So let's kind of look down here. Mrs. Simon drives her car from her home to her workplace every workday morning. Table above shows the distance. So this column is our distance. And her average driving speed in miles per hour. So this is my speed. One thing that we need to know for these type of problems is that distance equals speed times time. Then there's different variations of that if you want to solve for it. For instance, speed equals distance over time. Or if you want time is distance over speed. So you can kind of change those equations around. This one's easy to remember because it kind of spells out distance, DST. So number 37, on one morning, Mrs. Simon drove directly from her home to workplace in 24 minutes. So they're actually giving me a time of 24 minutes. What was her average speed in miles per hour during her drive that morning? All right. So basically, let's look at this. So try to figure out. It says, what was her average speed? So I think we can use this equation. So her average speed is going to be the total distance divided by the total time. That's the average speed. And so we do have a total distance here. We have 0.6 for the freeway entrance, whatever, 15.4. And then we have finally to get to work. So when you put all those together, it comes out to be 17.4 miles. So that's how far she's traveling to get to work. And she can do that in 24 minutes. But then we need to convert this to miles per hour. And there's different ways to do it. I'm going to kind of do it how like in science class they convert it. So if I want to end up with miles per hour, what I'm going to do is I'm going to multiply by a conversion factor. And since I want to keep miles and I want to get rid of minutes right here, I'm going to put minutes on the top. And ultimately, I want miles over hours. So I need to find a conversion there. 60 minutes is the same as 1 hour. That way I can cancel these minutes out, and I end up with miles per hour. So now you just multiply straight across. Multiply the top, multiply the bottom. And we end up getting an answer of 43.5 miles per hour. So you have 4 slots on the SAT, so you're going to bubble in 4, 3, the decimal point, and then the 5. All right, so one thing I want to point out just to make sure on this one is that when you multiply this top number, you're going to get 1,044, but then you do have to remember to divide by 24 times 1, which is 24. So that's kind of where we got the 43.5. Don't forget to divide by that bottom.